Hello everyone, I am Zainab Khan, roll number 205003, class BSc first year second sim of Isabella Thoburn College. This is my mathematics presentation and my topic is straight lines. Formulas. Straight line formulas will help us to solve different type of problems on a straight line in coordinate geometry. Uh, let's see the first one. If a straight line makes an angle alpha with the positive direction of the x-axis, the slope or the gradient of the line, that is m is equals to tan alpha. The second is slope of the line joining the points x1 comma y1 and x2 comma y2 is m is equal to y2 minus y1 upon x2 minus x1 is equal to difference of ordinates of the given point upon difference of the abscissa of the given point. Third, condition of collinearity of 3 points x1 y1, x2 y2 and x3 y3 is x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 is equal to 0. Fourth one, the equation of x-axis is y is equal to 0. We know that very well. And the equation of y-axis is x is equal to 0. Now, the equation of the line parallel to x-axis at a distance h unit from the x-axis is given by y is equal to h. The next is the equation of the line parallel to the y-axis at a distance k units from y-axis is x is equal to k. Next is the equation of a straight line in slope intercept form is y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. Next, the equation of a straight line in point slope form is y minus y1 is equal to mx minus x1. Sorry, where m is the slope of the line and x1 comma y1 is a given point on the same line. The next is the equation of a straight line in symmetrical form is given by this formula: x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to r, where theta is the inclination of the line. This theta is the inclination of the line, and x1 comma y1 is the given point on the same line, and r, this r is the distance between these 2 points x comma y and x1 comma y1. Now, the equation of a straight line in distance for r is x minus x1 upon cos theta is equals to y minus y1 upon sin theta is equal to r, where theta is the inclination of the line x1 y1, and of the line x1 y1 is a given point on the same line, and r is the distance of the point on this line for the point x1 comma y1. The equation of a straight line in 2 point for is y minus y1 upon x minus x1 is equals to y1 minus y2 upon x1 minus x2, sorry, or we can say y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1, where x1 comma y1 and x2 comma y2 are the 2 points on the given line. Now, The equation of a line in intercept form is given by x upon a plus y upon b is equal to 1. Where a is the intercept, a is the x-intercept and b is the y-intercept of the line. The straight line intersects the x-axis at a, 0 and the y-axis at 0, b. The equation of a straight line in normal form is given by x a cos theta plus y sin alpha, x cos alpha plus y sin alpha is equal to p, where p is greater than 0, is the perpendicular distance of the line from the origin, and a, which is between 0 and 2 pi, is the angle that the drawn perpendicular on the line makes with the positive direction of x-axis. P, which is always greater than 0, and a, which is between 0 and 2 pi. Now next, the equation of a straight line in general form is given by ax plus by plus c is equal to 0, where a, b and c are the real constants. A and b both are non-zero here. The next is to find the coordinates of the point of the intersection of two given lines. We first solve the equations. The value of x is the abscissa and that of y is the ordinate of the point of intersection. Now, the next is the equation of any straight line through the point of intersection of the lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is given by a1x plus b1y plus c1 plus lambda times the second line, means lambda times a2x plus b2y plus c2 is equals to 0, where lambda, which is not equal to 0 or infinity, is an arbitrary constant. The next is, three given straight lines are concurrent if the point of intersection of any two of them satisfies the equation of the third straight line. Next, let theta be any acute angle. The theta be any acute angle between the straight lines y is equals to m1x plus c1 and y is equal to m2x plus c2. Then tan theta is equal to, this is the formula for the tan theta. Tan theta is equal to m2 minus m1 mod of m2 minus m1 upon 1 plus m1 into m2, or we can also say that tan theta is equal to plus minus m2 minus m1 upon 1 plus m1 into m2. Now, next, if two straight lines are parallel, then their slopes would always be equal. Now, thus the condition of parallelism for the lines y is equal to mx m1x plus c1 and the line y is equal to m2x plus c2 is given by is m1 is equal to m2. Now, the equation of any straight line parallel to the line a1x plus b1y plus c1, here it will come is equal to 0, is ax plus by is equal to k, where k is an arbitrary constant. The next point is, two straight lines are perpendicular to each other if the product of their slope is minus 1. The product of their slope is minus 1. Thus, the condition of perpendicularity of the lines y is equal to m1x plus c1 and y is equal to m2x plus c2 is given by m1 into m2 is equal to minus 1. The next point says the equation of any straight line perpendicular to the line a1x plus ax plus by plus c is equal to 0 is given by bx minus ay is equal to k, where we know that k is always an arbitrary constant. Now, the next point is the two equations. What are the equations? a1x plus b1y plus c1 is equal to 0, and the equation a2x plus b2y plus c2 is equal to 0 represents the equation of the same straight line when a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Now, the next point says let ax plus by plus c be a given straight line and p, which is p is a point x1 comma y1 and q is another point x2 comma y2. These are the two given points. The points p and q are on the same side or opposite side of the line ax plus by plus c, according as ax plus by plus c and ax1 plus by1 plus c are of the same or opposite signs. They can be of the same sign or opposite sign. The origin and the point p x1 comma y1 are on the same side. They can be on the same side or the opposite side. Either they are on the same side or on the opposite side of the same straight line. What is the straight line? Ax plus by plus c is equals to 0, according as c and ax1 plus by1 plus c are of the same or opposite sign here also. They can be of the same sign or opposite sign. Now, next is let p be any point p x1 p x1 comma y1 be any point which is not lying on the straight line. Ax plus by plus c is the straight line and this p is a point which does not lie on this straight line ax plus by plus c is equal to 0. Then the length of the perpendicular drawn from p upon the line is given by this formula. The length of the perpendicular from p upon the line is given by plus minus a1x plus b1y plus c upon under root a square plus b square, or plus minus there is plus minus, which means that there must be a mod. We can also write this as mod of a1x plus b1y plus c upon under root of a square plus b square. The next and the last point is the equation of the bisectors of the angles between the straight lines a1x b1y plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equals to 0 are given by this formula. a1x plus b1y plus c1 upon under root a1 square plus b1 square, which is equal to plus minus a2x plus b2y plus c2 upon under root a2 square plus b2 square. If C1 and C2 are of the same sign, then the bisector containing the origin is given by this formula A1, which is a1x plus b1y plus c1 upon under root a1 square plus b1 square is equals to plus a2x plus b2y plus c2 upon a2 square plus b2 square. If they have the same sign, then we will get the positive value on the right hand side. And if C1 and C2 are of the opposite sign, then the bisector containing the origin will be here in this point we will get the negative sign only. There is no big difference. We will get a1x plus b1y plus c1 upon under root a1 square plus b1 square is equals to minus a2x plus b2y plus c2 upon a2 under root a2 square plus b2 square. That's all from me, from my side. Thank you.